All right. So standard form. Here we go. 5, 5. So we've seen slope intercept, point slope, and now standard form. And I'm going to show you how to graph from standard form. If it's in standard form, there's a pretty easy way to quickly graph the line using the x and y intercepts you may have seen before. So ax plus by equals c. Here are the 3 rules for standard form. X and y on the same side of the equation. Doesn't matter if it's on the left or the right. They could actually be on the right as well as the left, but same side of the equation. X term is positive, so we're going to keep the number in front of the x positive. And the third thing will be no fractions. Yeah. Something to celebrate. But ax plus by equals c, where a, b, and c are not fractions.
Wait, but there's a fraction like
that. Well, that's because it's not standard form. So what we're looking at is a bunch of different equations. These are all different linear equations, different forms. Decide whether the equations are in standard form or not, and if not, why. I think the why is important. There's actually one of these that is in standard form. All the others are not. And there's a reason why not. It's one of these rules. You don't see the only one? Okay, what's one? What about the first one? Is it in standard form?
Yeah.
Yes, it is.
So all the others are not.
They're not. So let's figure out why not. Why not this one?
Because they're negatives.
Yeah, it's rule number 2. So this is a no because it breaks number 2. What about this right here? That one's easy to see. Yeah, breaks number 3. That's a no. This one, same thing. Number 3. That's a no. What about this one right here? Yeah, it's number 1. So it's number 1 that it breaks. That's a no. Bunch of rule breakers here. And then this one is another number 1, so no. So when you're asked to put it in standard form, it needs to look like this. Ax plus by equals c, where a is positive, no fractions, and x and y are on the same side.
Wait, why is the number the first number 1?
First number 1.
Yeah.
This one? Oh,
Yeah.
This one?
Yeah.
Oh, because the x and y aren't on the same side. So the reason I put number 1 is it breaks rule number 1. The x and y are not on the same side of the equation.
I just read it wrong.
Okay. It's in slope-intercept form, which is great. I mean, that's a useful form for graphing, but it's not in standard. All right. So what are the x and y intercepts of the graph? So this is in standard form. We're going to find the x and y intercepts. I'll show you the process, and then I think you can. This is something where you don't need to necessarily show your work. As a matter of fact, I'd like you to be able to look at this and just tell me quickly and easily what the y-intercept is and what the x-intercept is just by looking at it. That would be the goal. That's what I do. So, but here's the process. To find the x-intercept, we plug in 0 for y, and then solve for x. It looks like this. So we have 3x plus 4 times 0 equals 24. That 4 times 0 term disappears. 4 times 0 is 0. So I have 3x equals 24. If I divide by 3, x equals 8. So my x-intercept is the coordinate 8, 0. And we're going to ask you to write the x and y-intercepts as coordinates and then graph them, plot them on the xy grid, and then draw in the line.
Wait, why'd you plug in 0?
Why did I plug in 0? Because I'm trying to find the place where the graph of this line, 3x plus 4y equals 24, crosses the x-axis. So by plugging in 0 for y, what that does is it places me somewhere on this x-axis right here that I'm coloring in green. If y is 0, I've got to be somewhere along here, right? And I'm finding that I'm at 8, 0. So you could probably then tell me how to find the y-intercept. Just it's kind of parallel to this process. What do you think? What do you think, B? How do I get the what?
How can you get 8?
How do I get 8? 24 divided by 3 will give me the 8.
Oh.
The 4 times 0 is 0, so that term is gone. All that's left is 3x equals 24. So what are we going to do here to find the y-intercept? Do you guys have an idea based on our process for the x-intercept? Yeah. Yeah. Plug in 0 for x. And so it looks like this. 3 times 0 plus 4y equals 24. And then I have just the 4y equals 24. And then 4 times what equals 24? 6y equals 6. That's another way to think of it, right? You just think of it. 4 times what equals 24? And you have the coordinate 0, 6. 0, 6. And we're going to build up to this point at which we'll plot those 2 points, graph them. Now, this is a lot of work to show. When you're plugging in zeros, we got to be able to do that in your heads. Matter of fact, I think of it kind of like as we call it the cover-up method. It's like cover up, to do it like this maybe. Cover up negative 6y. I mean, just get rid of it, blot it out, right? Because if I plug in 0 for y, that's what's going to happen to that term anyways, right? So I have this equation 5x equals 60 now, right? And if 5x equals 60, what does x equal? 12, yeah. So my x-intercept is 12, 0. And then if I take this equation again, I could clone it here. Take this equation again. So in this one, we blotted out. If you want to, you could rewrite. Write it twice. You might want to show the blotting out part. But 5x equals 60. Here I would blot out the 5x instead. Be careful, don't blot out the negative sign. We want that negative sign to be in there. So if I blot out the 5x or cover up the 5x, we have negative 6y equals 60. And so y equals negative 10, yeah. So that gives me a y-intercept of 0, negative 10. Now, to be honest with you, I mean, I can do this in my head. I think any of you guys could too. So when you're doing a skill test, I mean, you need to list them as coordinates. You need to graph them. But if you can find the x and y intercepts just in your head, if you can do it mentally, that's great. That's what I do. Look at it. You can look at it and think. 12 July. Oh, good question. It'll be a fraction. That's okay to be a fraction. You could just leave it 12 over 8. But 12 over 8 simplifies to 3 over 2 is how we write it, or 1.5. Okay, we're going to tell you. But I don't. So right here, let's see if you guys can do this. What is the x-intercept? Just looking at it. 4. Yeah. So we got 4, 0. And then this guy, this is what she was asking about. Well, this 8 doesn't go into 12 evenly, right? But that's okay. It's just 0. Yeah, 1.5. You could write as 1.5, or probably you'd see it like on a multiple choice test, probably written as 3 over 2. So simplified. Here's what we have. It's 12 over 8. It could be written as 3 over 2. Like if I'm going to graph it, I'm going to think of it as 1.5. I mean, I'm not graphing 3 over 2. I'm graphing 1.5 or 1.5. So all are correct. That's it. I mean, you just the cover-up method. You're just doing what I did up here mentally, and that's the beauty of having it in a standard form and being able to graph it. It's really easy to do. Same thing with slope-intercept form. I mean, you could probably do all that too in your head. There's no work to be done. You just place the dot at the y-intercept and then do what the slope tells you to do to get in the dot. Draw a line quickly. So it's something that, as you move on in math, you're going to see lots of linear functions. You want to be able to graph them quickly and be able to see, where do they cross the x and y axes. I'll show you a real life problem later on where the x and y axes are kind of like key points. The x and y intercept are key points of the graph. All right, graphing using intercepts. So this is what your skill will look like. This is what your skill. It's in standard form. We're going to find the x and y intercept. So if we just cover up here, this guy, what is the x-intercept? X is -2, so we have -2, 0. That's our x-intercept. And then if I take and clone this guy and do a cover-up on just the x, just gotta really watch the signs on here. I know students will, maybe just not see this negative sign here, and that'll mess you up. So just be aware of that. But -2i equals -2. Can you solve that? Yeah. Because we divide each of these by -2, we have y equals +1. So 0, 1 is the other point. So I just plant 0, 1 on here on the y-axis, and I plant -2, 0 on the x-axis, and then I draw a line through the two. And that's it. So it's pretty efficient graphing that. Why don't you try the next one, see if you can graph that. See if you can locate the x and y intercepts just by looking at it. Be sure to list them. I will ask you to list them on the skill test with the zeros in the correct place. All right, 0, 4, 10, 0. Connect the two. That's good. We're going to look at vertical and horizontal lines. You think of vertical lines would be like this wall over here. This is a vertical wall. So vertical lines go this way, up and down. Horizontal would be like the floor or the horizon. Horizontal is like the floor, so they're level. Slope is 0, undefined slope. So y equals 3 would look like this. A lot of students will put a dot on the y-axis at 3 and leave it at that. Okay, it's not a dot. It's not a coordinate. What we have here is a line. And what this is saying literally is y is always 3. So you could give me any x coordinate you want. It could be -3. Well, x coordinate -3 will give me a y coordinate of 3. X coordinate of 0 is y coordinate of 3. Yeah. Here's what I can tell. If, like, when it says y is 3, you're going to put a dot at 3 on the y-axis, right? And then you're going to just draw your line through that dot. Going this way. I mean, it's the way I think about it is it's just saying y is always 3. So this line stays at 3. Not at, if it were going this way, it would be staying at 0 because it would correspond to the x, not the y. Does that make sense? So this is saying y is 3. This is telling me x is always 3. So I'd go over to the x on the x-axis, put a dot at 3, and then keep my line always at 3. There is no y involved in here, so y could be anything, and that's what this is showing, is y could be anything. But x is always 3. So x is always 3. So why don't you try these just quickly, see if you can graph each of those. I want to say one thing about the y equals 0. That's a special horizontal line. Corresponds to something. See if you can graph each of those. So we have a couple of vertical lines here. These are vertical. And then these guys here and here are horizontal. And what's special about the line y equals 0 is that is also the x-axis. So we have equations for the x and y axes. What do you think the equation for the y-axis would be? Yeah, x equals 0. So that'll show up as you go through math. But they would reference this as y equals 0, x equals 0. Horizontal and vertical line. All right. This probably seems a little backwards to you. Sometimes it is. We probably change standard form or point slope form to slope intercept form more often than we would change slope intercept form to standard. But we need to know how to do it. We should know how to do the algebra to change this. So here's the process to change this. Remember, it's all right here. I can remember the rules for standard form. X, Y on the same side. X term is positive, no fractions. So I've got to first get X on the same side as Y. So we're going to add the 3/7 X over. So if I add 3/7 X to each side, it's just, I could think of it just moving it over. So we have 3/7 X plus Y equals 5. Really, you're adding 3/7 X to each side, but because the Y is not a like term with the 3/7 X, you can't join those together in any way. You just write them next to each other. So are you okay with that? Moving the 3/7 X over to the left to get the X and Y on the same side. The other thing we accomplished here is we took this negative in front of the 3/7 and made it positive by moving it over here. If this happened to be positive already, I would just leave it on the right-hand side and actually subtract the Y over instead. Okay. So it doesn't matter if the X and Y are on the left or on the right. What you want is to have them on the same side with the leading coefficient or the leading term, the A, positive. And then one other thing, we need to have no fractions here. So you have any ideas on how to get rid of that 7 in the bottom of the fraction with the 3/7? So pretty good. Yeah. Do math. It'd be nice to get rid of the 7. You could times it by something, yeah. And there's lots of, I mean, we could times it by whatever we want to times it by, as long as we multiply every term by that number. What I would do here is go ahead and multiply it by a positive 7. So you're right, it's multiplied by a 7. In this case, I would make it positive 7. You do it on each side of the equation, just because we have to keep that balance. But you can multiply it by, you can multiply it by a negative 7 if you wanted. That's if you had moved the y over here and the 5 over to the left, you'd have a negative in front of your y, a negative in front of your 3/7, and then multiplying it through by a negative 7 would get rid of that negative in front of the x term. So you have more power than you might think. You just have to follow the rules. I mean, if you wanted to, you could multiply through by 14, or 21, or 28, or 35, right? Just to be a character. Just multiply through by 35, just for fun. But typically, we'll just multiply by maybe the least common denominator of all the fractions. Is typically what we do. So 7 times 3/7, we're going to distribute here. 7 times 3/7 would be, the 7s would cancel. That was the whole point of multiplying by 7. That leaves us with 3x. And then a lot of students will forget. It's like all the mental effort it takes to multiply a number by a fraction. I don't know. But 7 times y would be 7y. Don't forget to distribute, and then equals 35, and you're done. So that's standard form. What I have right there, 3x plus 7y equals 35, is equivalent to negative 3/7, y equals negative 3/7 x plus 5. It's just as easy to graph in this form. So typically we are going the other direction. You'll find in math, we usually want to be able to simplify or go both directions on a lot of things. I hand you the equation, you give me the graph. I hand you the graph, you give me the equation, that type of thing. Being able to work both ways. Here's one in, do you recognize this form from last time? Remember the name of it? No? This is point slope form. So to go from point slope form to standard, I'm going to actually first distribute to negative 1/3 x. And here's how it works. 6 times 1 is 6, divided by 3 is 2, and there's a negative sign out in front. So that's minus 2. And then I'm actually going to change this into slope-intercept form like the one above it before I change it to standard form. And I'm going to do that by adding 2 to each side. So I have y equals negative 1/3 x. And the negative 2 and positive 2 cancel out to equal 0. So that makes it kind of different, easier, I guess. So there is no, well, there's a c. C is 0. I'm going to add the 1/3 x over to the other side. So when I move it over, I'm going to make it positive 1/3 x plus y equals 0. Okay, I still have a 0 as my constant over here on the right. And to get rid of that fraction, I'm going to multiply through by 3 in this case. So take 1/3 x plus y, multiply that by 3, 0 times 3. So 3 times 1/3 is 1x plus 3y equals 0. You typically won't see that 1 written in front of it. It'll just be x plus 3y equals 0. That's how you would see it written in standard form. But it's okay to have a c equal to 0. 0 is an integer. All right. Last one on here. This is one where the x and y intercepts would be important, like end points of the graph. This line would be an example of one that you wouldn't put arrows on. It doesn't keep going. It's just a line segment that you could connect across here. As a matter of fact, if you really only have $60 exactly to spend and you're going to spend that amount, it would be a discrete graph. If you could buy part of a movie or part of a song, I guess you could have things in between. But it says a media download store sells songs for $1 each and movies for $12 each. So we might have, if X represented songs and Y represented movies, then we would have 1X plus 12Y equals 60. So that's the equation. If I wanted to graph this equation, I could find the X and Y intercepts by covering up the 1x. So if I cover up the 1x here, we have 12y equals 60. What does y equal? 60 divided by 12. 5. Yeah, in other words, if I were making a table here, and I go ahead and buy 5 movies, that's going to use up all my money, right? I would have nothing left for songs. So I'd have 0 left for songs. So up here we have 0, 5 is one of my intercepts. 0, 5 is one of my intercepts. That's just solving 12y equals 60, y equals 5. If I take and cover up the 12y, I just have 1x equals 60. So that would be a dot down here. So if I were to connect these two, make a continuous line, there it would be. It's all in the first quadrant. I could buy 5 movies and no songs. I could buy 60 songs, no movies. That's the other end point here. And then everything in between. So I could, what if I bought 4 movies? That'd be 4 times y would be $48. I'd have How much left for songs?
Oh wait.
Oh, yeah. So 4 times 12 would be 48 out of my $60. Yeah, 12 more left. And you'll see a pattern develop here. If I buy 3 movies, $36. So now I have 24 left for songs. You could probably tell me the next 2 here, 2 and then 1. So it'd be 36 and then 48. So that's actually all the combinations. They asked for 3 options. We just gave them all the options. If you can only spend $60 exactly, that's what I'm assuming. So if you're going to spend the whole $60, that's how it will work. It says, suppose the store charged $15 per movie. What would change here? Still have 1x. It'd be 15y equals 60. So a slightly different equation. If I change the price of the songs, then that would change. Movies can stay the same. What domain and range values are logical for this new situation? Now, if I'm assuming that you can only buy whole movies and whole songs, which I am, and that you're going to spend the whole $60, the domain and range is not corresponding to a continuous function like I drew up here. The domain, let's think about this for a minute here. We'll draw our D in our fancy bracket, the range in our fancy bracket. Let's make a little table over here, X, Y table like we did on the previous one. And, if I bought, okay, if it's $15 a movie, the most movies I could buy would be 4 of them. That would bring me right up to $60. And I would have 0 songs. If I bought 3 movies, that'd be $45, leaving me $15 for songs. Okay. So that'd be 15. 2 movies would be $30, so I'd have $30 for songs. 1 movie would leave me $45 for songs. If I got 0 movies, I could just go crazy with songs, 60 songs, $1 song. So my domain really is just only the X values I've listed here. So they are 0, 15, 30, 45, and 60. And the range would be 0, 1, 2, 3, 4. And this is a function. There are no 2 X coordinates that are the same for a different Y value. Right. So in summary here, I might want to say something about how you find, the big idea here is how you find the X and Y intercepts so you can graph it in standard form. So, if I were to summarize this, I might say something about, AX plus BY equals C. You could do this. This is to find Y intercept. And if I wrote down AX plus BY equals C, cover up or take out the Y term to find X-intercept. So instead of the AX plus BY, cover up the BY, you can get the X-intercept. Cover up the AX, and you can get the Y-intercept. Quick and easy way to do this. I have some crossword to try. So crosswords on the pink sheet.